Welcome to Ravi's Academy. In today's class, you will be learning isometric projections and isometric scale. And let us see the first topic, isometric projections. The basic principles of isometric projection completely derived depending upon a cube. Let us look at this cube. Cube is resting on one corner on HP such that the front corner and the rear corner joining these two is called solid diagonal. The solid diagonal must be perpendicular to vertical plane VP. So, this is the orientation of the cube. In this particular orientation, you can see that a cube is having 6 faces and all 6 faces will be having identical parallelograms, as well as you can see that you have 12 edges. All the edges are equally reduced in size, and that is the reason we call it as isometric projections, and all are equally reduced in certain proportions. That proportion we are going to derive in this particular class. Now, I am keeping this on this particular corner, and this particular view I am going to draw on the board. Let us look at this and understand how exactly it happens. Now, let us draw a horizontal line, and to the right at an angle 30 degrees draw a line, and to the left also draw a line at an angle 30 and vertical line. I am going to construct this cube with isometric view, and let us see how exactly it happens, and you can understand it how it reduces in sizes in equal proportions. Let us see, this is the cube. Let us assume that this cube is having 100 mm size, and obviously you can see that the size, because each and every edge is inclined at certain angle, and because of this inclination you can see that all the edges as well as the planes are reduced in size. That you are going to see practically how it happens. Now, in this particular position I am joining these two corners, right, and the true length, let us assume that it is at an angle 45. This you know that it is at an angle 30 degrees, and the true length will be at an angle 45. So, from this right triangle, I have drawn right triangle, you can see, and from this we are going to analyze. Now, you call this as O, I am calling this point as R, and this as A, and finally this as B. From triangle ORB and ORA, you are going to obtain how much it is going to reduce. Let us look at this. From triangle ORB, you can write down OR is equals to, it is OB cos 45 degrees. Similarly, from triangle ORA, the same length OR is equals to OA cos 30. Now, we are interested in, these two are equal, we are interested in OA, that is what is exactly the isometric length. Now equating these two, OA cos 30 is equals to OB cos 45, and OA is equals to, it is OB times cos 45 divided by cos 30, and you are going to get OB times, it is 0.816, and OA is nothing but isometric length, and OB is nothing but your true length of the cube. Now, this value you can see that 0.816 is the size, or the edge is going to reduce by it is the size you are going to obtain is 0.816 times, means it is 81.6%. It is something like a gold, you know that it is 916, now it is 816. So, 916 is 24 carats of gold. Similarly, here the size you are going to obtain, that you can remember in the similar manner, 816 means it is 81.6% of the actual size. Now, the scale, I am talking about the scale. Now, let me expand this magnified view of this I am writing it as OR is the reference line, and this OA at an angle 30 degrees and OB at an angle 45 with horizontal, and erect the vertical. Here whatever you mark the dimensions on OB or the true length, this line is a true length, and whereas the dimensions on this OA is isometric length, it is called iso length. That means it is going to reduce by 81.6. That means whatever dimension you want to mark, you can mark on true length line and erect a vertical perpendicular to reference line OR, and where it intersects OA at a point, that is what is your O. Let me call this as C. OC is the actual length and OD is the iso length of the corresponding particular dimension. So, that is what is known as isometric scale. Thank you.